So yesterday we talked about analyzing arithmetic sequences and where you found out that you had a common difference. Your sequences were going up by a constant. Well, today we're going to look at geometric sequences, and the definition of a geometric sequence is a sequence with a ratio of any term to the previous term, called a common ratio. So what that means is I am looking for something that is being multiplied by the same number. So in my example, 1 to 2, I went up by 2, so I multiplied by 2. And from 2 to 4, I went multiplied by 2. Sorry, my multiplication signs don't want to look very good. And 4 to 8, I times by 2. So my common ratio is going to be 2. If I was to look at a visual for it, I am going to notice that my graph is exponential. So arithmetic was linear. This one is going to be exponential. So this is my exponential growth. Don't forget you could have an exponential decay if you're going down by a negative, right? If I'm looking at a table, I'm still looking for the term to the sequence number. I'm going to look for a common ratio there. What's going to be interesting about this is that the number in this one that we're talking about here, again, we multiplied by 2 on all of these. This, if you remember last week when we were doing them, every time I had something like this, if it was exponential, this was the base of my problem, and then your term numbers ended up here in the exponents. So we have a formula for all that, and our geometric formula is right over here. A sub n equals a sub 1, which is my first term, times my ratio to the n minus 1 power. So if I'm defining all of those, again, the a sub n is my term value for whichever term number we're talking about, right? The a sub 1 is my first term of the sequence. The r is my common ratio that you found in your sequence, and sometimes you might be given it, but it's my common ratio. And the n up here is my term, is the position in the sequence. Like, was it the first one? Was it the second term? But it's the position of the sequence, or position in the sequence. Okay? It's also that little number that you have attached to that n right here, the a sub n. All right. So kind of different ways that you can look at it, what you're seeing. I would encourage you to write that down somewhere because there's a lot of really good information that will help you separate things there. But let's go ahead on our first 4 terms and let's just look at if they're geometric or not. So we're going to look at these 4. So on the first one, our sequence is telling us to see if it's geometric or not. And we're going on the first one, 6, 12, 20, 30, 42. So I would probably look at a variety of things. One, I multiply by 2, right? Well, 20 to 12 is not multiplied by 2. So I know at this point in time this is not geometric, because this is not 2. I don't know what it is, but I know it's not 2. So it's not constant, so it is not geometric. If I am looking for number 2, 256, 64, 16, 4, 1, I honestly cannot tell you. If I was just looking at that, I'd have to do some search to figure out what this ratio would be. And when I do that, I would do the term behind it divided by the term in front. So 64 divided by 56 would end up being 1/4, so a fourth of it. On this one, it'd be 16 over 64, which would come down to 1/4. I do know that 4 over 16 is 1/4. And if I did this, 1 over 4 would be 1/4. So this is a constant. Everything is decreasing by a fourth, right? So this is geometric. Right? So again, I'm looking for that constant thing that you're multiplying by. Looking at number 3, I am looking to see what the graph would look like, and this one does fall, right? It's just kind of a decay. So this one would be geometric. It's got that exponential decay instead of exponential growth. Number 4 is not a decay. Actually, it's a straight line, so I would actually know number 4 is arithmetic because it's linear, but today we're just asking to say that, hey, it's not geometric. Just to keep those other vocabulary words in there for you. All right, so you're going to look at some sequences, tell me if they're arithmetic or geometric or not. All right, then let's get down to using that formula. On the last 4, we're going to write a rule for the nth term. So we're going to write the general rule for the sequence, and then we're going to find a sub 8. We're going to actually use that rule. So the first thing I'm going to start by is going, what's happening between my term values? So I got 10 to 20, 20 to 40, 40 to 80. Hopefully you noticed, hey, these are all being multiplied by 2. So what I have there is that my common ratio is 2. The other thing I'm going to need is my a sub 1. Hopefully you know what that first term is. And that term value in position 1 is 10. And then we're just going to grab our formula. A sub n is going to equal, on geometric 1, it's the first term times the ratio to the n minus 1 power. So I just need to plug those things in. So my a sub n, my first term is 10, so I'm going to do 10 times my ratio of 2 to the n minus 1 power. And my sequence is written. Actually, in some aspects, it's a lot easier than having to simplify after the arithmetic one or multiplying it all out. All right, so now we're going to go in and we're going to find a sub 8. So I'm going to put, what that's asking me is, what is the value of the 8th term? So to do that, I'm going to do 10 times 2 to the 8 minus 1, so to the 7th power. I'd probably type that all in my calculator. So 10, 2 to the 7th power, I did not do yet. So 2 to the 7th power is 128. So 10 times 128. The 8th term value is 1,280. Not so bad. All right, number 2, we're looking at 88, negative 44, 22, and negative 11. And you're going to notice, hey, that is actually decreasing. 44 is half of 88, 22 is half of 44, and 11 is half of 22, and they're all going to be negative because it's a negative divided by a positive, positive divided by a negative, and so on. So my ratio is going to be negative 1/2. My a sub 1, my first term is 88. So let's plug that into our formula. My a sub 1 is 88 times my rate, which is negative 1/2 to the n minus 1. And then when I find my a sub 8, I'm plugging 8 in for my n. So 88 times negative 1/2 to the 8 minus 1 power, or to the 7th power after I do that. If you do all that correctly, you should either come up with, a sub 8 would equal 11 over 16, negative 11 over 16, or as a decimal, it was negative 0.688. Hopefully I did that one correctly. All right. Let's look at the last 2, our decimals and our fractions. So what happens here? On the first one, remember, I'm going to, when I work this out, it would be 2 divided by 6, which would be 1/3, right, if I reduced it. If I took 2/3 divided by 2, and I know you can do this on your calculator too, but remember I multiply by the fraction, and I would get 1/3, and 2/9 divided by 2/3, I have to multiply by the reciprocal again, which would be 6/18, which would be 1/3. So I have a common ratio of 1/3, and a lot of that you can do on your calculator. And my a sub 1, my first term is 6. It's in the first position. So let's rewrite our formula down. That's geometric is the first term times the ratio to the n minus 1 term. We're just going to plug in our information. So a sub 1 or a sub n would equal 6. I'm just writing my general term of r to the, whoops, I forgot to put my r in. My r is 1/3, right? I don't know what just happened there. Okay. 1/3 to the n minus 1 power. So there's my general sequence. And now we're just going to plug a sub 8 in there. So I'd have 6 to the 1/3 to the 8 minus 1. And you might have to put 8 minus 1 in parentheses if you're doing it in your calculator, but make sure you're doing them correctly. And you should end up with 2 over 729, or approximately 0.003. Okay. All right, let's look at that last one there. We've got 1.3, negative 3.9, 11.7, negative 35.1, and if I start working those out and I do negative 39 or negative 3.9 divided by 1.3, I find out that, hey, this is negative 3. And if I do 11.7 divided by negative 3.9, I get negative 3. And if I do negative 35.1 divided by 11.7, I get negative 3. So it is geometric, and I have a common ratio of negative 3. My a sub 1 is 1.3. So we're going to plug that in. So a sub n would equal a sub 1 times r to the n minus 1. Let's plug in the information we have. A sub 1 is 1.3. My rate is negative 3 to the n minus 1, or my ratio is negative 3 to the n minus 1. And actually that n up here, shouldn't be an n. Remember, we replaced that. Oh, no, I'm still right. I'm writing the right one. Sorry. I was thinking I was subbing 8 in there already for it. All right, so here's my general term. And now we're going to find that a sub 8. So we're going to put 8 in for our n. So negative, or 1.3 times negative 3 to the 8 minus 1. Type all that in my calculator. And I end up with approximately negative 2,843.1. All right, so now you've gotten to see arithmetic and geometric sequences. I'll see you tomorrow.